Hey guys, we are finalizing, ending this section with the last operation with radicals, and that is division. And now technically we're not actually going to divide these fractions, we're just going to rewrite them in simplest form. And we said that with simplest form we cannot have square roots or radicals in the bottom of a fraction. So we are going to do what we call rationalizing the denominator. And by rationalizing, we are changing something from an irrational number on bottom to a rational number on bottom. And again, I mean, it's just like life. We don't want something irrational being our base and our foundation, right? We want to be based on something rational, something that makes sense, something that doesn't just repeat or doesn't repeat and just goes on and on and on. So fractions feel the same way. They would like a rational foundation to their fraction. So we're going to help them by rationalizing the denominator. By rationalizing, again, we're changing the denominator from an irrational number to a rational. And to do that, we're going to multiply it by a form of 1. And the form of 1 depends on what the root is. So in this case, if it's just a square root, square root of 7, then we'll multiply by that square root, the top and bottom. Again, you have to multiply by 1, so we multiply the top and bottom. Multiplying anything by 1 doesn't change the value of the number, it just changes the form of the number. So if I were to plug this in my calculator and the final result, you'd see that the decimal equivalent is exactly the same. Now if it's not a square root, but like a cube root, fourth root, whatever, then you'll multiply by whatever power b is raised to, you will take n minus that power here. So for instance, this is the fifth root of 2. What do I multiply by? Well, it's a fifth root, and 2 is raised to the first power. So 5 minus 1 is 4. So I'm going to multiply by the fifth root of 2 to the fourth here. And the reason we do that is because on bottom, when I multiply these two together, think about that, the fifth root of 2 times the fifth root of 2 to the fourth, we can multiply these things on the inside. 2 times 2 to the fourth, 2 to the first times 2 to the fourth is 2 to the fifth. And so we do that so that we get the fifth root and to the fifth power cancel each other out, so we just get the 2 here. Now if it's not just a single fraction on the bottom, or excuse me, a single radical on the bottom, maybe it's a radical expression like 2 plus root 3 or something like that, then we're going to multiply the top and bottom by the conjugate of the bottom. So if I have a rational expression a root b plus c root d, the conjugate would be the exact same but with the opposite sign. So we'll look at examples of that. Now we're going to start with this one here where we want to simplify this. Remember, simplest form, there's no fractions inside the radical sign. So, excuse me, we will first start by separating this into the top and the bottom. Now before you start rationalizing, it's probably helpful to simplify top and bottom first. The bottom really can't be simplified. However, on top, the 250 and a to the 6th, they do have cube root factors. So if you think about it, 250 is the same as 125 times 2, right? And 125 is one of our perfect cubes. So we can simplify that top. Cube root of 125 is 5. And also we can take the cube root of a to the 6th. a to the 6th, 6 divided by 3 is 2. So that can all come outside the cube root, and that'll make it a little easier. And then there's still the 2 inside the cube root. That'll make it a little easier when we want to simplify and rationalize here. So first, separate and then simplify anything you can. All right. So now we are going to multiply top and bottom of this fraction by a cube root. What cube root would we multiply by? Well, this is 7 to the first power and a to the first power. And 3 minus 1 is 2. So I'll multiply by 7 to the second and a to the second power on top and bottom. Now the nice thing is on bottom, what that does is that cancels out that whole denominator, or that whole cube root, because we would end up with 7 to the third, a to the third under the cube root. And on top, again, we have that 5a squared outside, and these we can combine because they're both inside cube roots. So 2 times 7 squared which is 2 times 49, is 98. And then there's an a squared as well. Okay. So now we're down to this right here. But there's one more thing we can do. We can simplify one of those a's. So our final answer would be 5a cube root of 98 a squared. And it doesn't look like it's not necessarily a simpler looking expression, but the denominator is rational here. So that's kind of what we're going for, is just getting the base to be rational. We don't want an irrational foundation, right? Okay, so that's what the fraction wants as well. So now it's steadily resting on this rational number 7 versus this irrational number 7a. All right, let's look at when they're conjugates of each other. So when it's not just a single expression here, and we'll just kind of ignore all this. I'll do this with you guys. We have this square root on the bottom, and then it's attached to all this other stuff. So the conjugate of 2 root 7 minus 5 would be 2 root 7 plus 5. So we're going to multiply the top and bottom by 2 root 7 plus 5. So on top here, distribute the 4x, and I'll just use this instead of trying to see if my screen will write for me. So we're going to distribute the 4x here, okay? And just looking at the top still, 4x times 2 gives us 8x root 7. 4x times 5 is 20x. So the top, that's all we do, distribute. There's nothing really we can combine here. On bottom, now the nice thing about the bottom, and I don't know if we've talked about this, but if you're multiplying something by its conjugate, again, normally we would take this expression and we'd have to FOIL, right? But if you're multiplying something by its conjugate, I think we've said this, we could just FOIL, right? We don't have to do the outer and inner. These two terms, these outer and inner terms, are always going to cancel out if they're conjugates of each other. So we can really just multiply the first terms together, 2 root 7 times 2 root 7, and negative 5 times positive 5. So when you're multiplying something by its conjugate, instead of FOIL, you can just FLO. And so 2 root 7 times 2 root 7 would be 2 root 7 squared. 5 times 5, negative 5 times 5 will be negative 25. So again, those middle terms just cancel each other out. 2 root 7 squared, the 2 squared would be 4, and the root 7 squared would just be 7. So that's where this 28 comes from, and 28 minus 25 is 3. So we can save ourselves some steps on the bottom here. When we're multiplying by the conjugate of the top and bottom, then you don't have to worry about multiplying those outer and inner terms because they will just cancel each other out. So our final expression, again rationalized, is this. So that is all we have for the rest of this section. Hopefully you guys will do okay, help each other out in class going over this since I won't be there. You guys can work together, and I think I gave you a lot of odds so you can check your answers as well. So good luck and have a great weekend since I won't see you until Monday. Okay, bye.